Hey guys, in this video I will be discussing thumb theory. Yeah, I know it's boring, but well, it's essential to know how computers were made, right? So let's get started. First, let's start with a small debate. Um, who's smarter? Well, most of you will think that the computer is smarter. Well, actually, it's shocking, but it's a draw. The computer is a dumb machine. Yeah, you heard it right. The computer are stupid machine because without our instruction or code, it cannot perform anything on its own. It needs our guidance. So, what can a computer do? So, it can do computation, running software, anything you can program it to do. How computers do stuff? The computers only understand machine code. So, each machine code specify a specific instruction. Inside the computer, there's some switches that are turned either on or off depending on your code. But don't worry, guys, if there's some ambiguity in this, all will become clear later on. So let's talk a little bit about thumb theory, about Alan Turing and binary and hexadecimal. So let's talk about the Turing machine that Alan Turing, the father of computing, created. So what's a Turing machine? It's an abstract machine that can manipulate symbols on a tape depending on a table of rules. And any computer program can be modeled as a Turing machine implementation. So basic, don't worry if it sounds complex. We just need to understand that any computer algorithm or computer software can be modeled as a Turing machine. A Turing machine is simply that has an infinite tape. You read, for example, this 0 or 1, and according to some rules, you can modify it. And yeah, it can read only one symbol at a time. So what is binary? Binary is a primary language that a computer can understand. It's base 2. So in school, we learned the decimal. For example, it's base 10. For example, the number 24 in binary can be represented as this number here. So how can we do it? So we do times 10 because it's 24, so it's 20 plus 4 times 10 power 0 because we have the 4 right here, right? So this is the composition of a decimal number. And now in base 2 we do actually the same, but we have 1 and 0 because it's base 2. Either it's 1 or either it's 0. Remember when I said it's a switch, either it's 1 or 0. So in binary we converted this number to binary. How we can do this? So 24 basically can be represented as this number. So we start here by 2 power 0. It's 1 but 0, so we don't use this. Then 2 power 1, 2 power 2, 2 power 3, 2 power 4. 2 power 4 is 16. 16 plus 8 is 24. So this is how we can represent the 24 decimal number in base 2 and binary. So here it's 24, it's 2 exponent 4 plus 2 exponent 3. So now hexadecimal is base 16. So why we use hexadecimal if a computer is based on binary? Because some stuff in the computer like the registry and the color code are based on hexadecimal, so it's nice to understand it. So it's from 0 to 9, then the 10 is represented by A, and the 11 by B, and the 12 by C, till the F. So first, let's convert this binary number to hexadecimal. So we compose it on a 4 elements, so 4, 4, 4, 4, sequence of 4. And let's here remember what we said. 2 exponent 0, it's 1, and here it's 2 exponent 3, it's 8. 8 plus 1, it's 9. Here it's 2 exponent 1, it's 2. And here it's 8, so 8 plus this one is 2 is A. And here it's 8 plus 4, it's C. And here it's all 1, 1, 1, so it's obviously F. So this is it for this video. So please guys, smash the like button below and subscribe to this channel for more awesome content. Thank you guys. Bye bye.